me? All right, so first off, thanks to all of you who are still in the hall. I appreciate that this has been a pretty long day with lots of sessions. So I'm going to try and keep my speak a little bit short, but hopefully informative for you. Okay? How many of you are familiar with energy storage solutions in general? Show of hands by anybody. Thank you, sir. I appreciate that. Okay, so then maybe that's where I start. So what is energy storage? So when we heard the leader from Sun Mobility talk about storage, he spoke about it at a EV level, which is at a consumer level. What battery energy storage solutions are is at a grid scale. Okay? So let me simplify that for you. So renewable energy, which is energy generated through the solar, the wind, is perishable. Means what you generate that particular day has to go into the grid, otherwise it's not usable. So what happens to the millions of dollars of investment that companies would be making in actual energy generation? It would go to waste because some days it's too sunny, too bright, heavy energy generation, and some days it's not, right? So if you did have a storage solution, which means an ability to store what you generate, and you're able to discharge at will, chances are you're going to make a lot more money out of it. So that's really what energy storage as a concept is. Let me say a few words about Fluence and what Fluence is, so that you'll have an idea of what is it that we really do and why intelligent storage is so important for this whole thing. So Fluence actually started out as a joint venture between Siemens and AES with the intention of actually accelerating the transition of how the world generates power into renewable energy. That was the goal, right? And fast forward the last 6-8 years that we've actually been a publicly traded company, we are now operating across 48 markets and we service customers around the world. So I spoke to you a little bit about what is energy storage. Let me talk to you a little bit about what is our product. So when you think about the landscape of the market, there's broadly 3 types of customers that we address. One is power producers, which is organizations that invest in the generation of electricity through renewable energy. The other is grid operators, which is people who actually operate the way that electricity is transmitted through grids. And the last is end consumers like you and I. Okay? We service the first two. And what we do is we actually make it possible for power producers to give predictable supply to the grid. So we manage that fluctuation. We also be able to support the grid operators in terms of how do you actually relieve congestion. So sometimes you heard the term overload, shutdown. All of that happens when multiple sources of electricity go into the grid and the grid is not able to take it. So our product sits between the power production and the grid and is able to stabilize it. Now, what is this product? The product is actually, how would I say it? It's a combination of hardware, which is these huge boxes, which are filled with almost up to 24,000 components, which includes batteries, array telco racks, transmitters, the whole works that makes storage possible. On top of it, you layer it with an operating system, and that is where the intelligence starts stepping in. An operating system that actually understands how to manage the system remotely around the world and how to be able to maximize the value that you can get out of the energy storage. And then over it, you layer it with some even more interesting AI technology that allows you to optimize the value the customer can get by, let's say, how much should I sell it in the market for? How do I use it for prediction? How do I actually better the optimized efforts of the actual product so that we know that the battery life can be extended? And finally, how do we actually look into the analytics and the data to inform us on how to make these products better, right? So if I take a second on what does this life cycle look like? So in a typical energy storage implementation type of situation, it always starts with permitting. The government has to permit you to do it because we are talking about very large power installations that have to be completely well integrated with the grid, and that calls for certifications, that calls for a whole ton of compliances, because you cannot afford any sort of safety risk. So which means they're first of all going to choose a partner who has a proven safety record of doing such things. And then from the permitting, you go on into, actual design of the project, which means that these are not just standard boxes you go and install everywhere. These are systems that you put together to do a fit for purpose for the customer, depending on the use case, right? So some use cases could be, let's say, for peak power, means power consumption peaks at a certain point in time of the day. And sometimes people use the storage solutions to address the peak power gaps. In that case, then you sort of customize how that solution is put together and you're able to deliver that. And eventually you come into the installation, commissioning, the energization. And after that, when the product gets into actual functioning, which means now it's live, it's working, the intelligence in that product is what actually makes the product. And right through this chain, you would actually see intelligence. So, when you think about permitting, for example, you might think it is just a lot of paperwork and, filing and talking to the government and authorities. Actually, it's a lot more. We run what is called grid studies and grid modeling, which means how will our product work with the actual grid code of that particular land. So, the grid codes of Germany, very different from grid codes of Australia. So you have to actually model to say this will work and here's how it works, and that is how the certification happens. That certification process in many countries is easily up to 12 to 24 months. That's an awful lot of time to tie up capital and wait for permits to come, right? With the intelligence that we have built into the system, we are now able to bring that down to less than 6 months. But yes, it still takes 6 months because you have to go through that process with the authorities, right? And likewise, you go into, let's say, asset management. I spoke to you about, some of our tools that we layer on top of our products. One is Mosaic and the other is Nispera. Very, very interesting products. Nispera, for example, is so intuitive about predicting the asset performance. It actually monitors, I told you roughly the 24,000 components that we might be having. It can actually monitor where is there going to be a failure and predict that failure and be able to initiate the necessary service needed to prevent that failure. And what that means is the system can then stay available for almost 99% of times, and that's a lot. The other software that we're talking about, which is the Mosaic, we call it the bidding tool, right? I told you very briefly what does bidding look like. In many, many markets, you produce the power, there is an energy exchange, and you're supposed to bid in that. It's like a stock market. Imagine it like a stock market. And in a stock market, anybody with more information than the other is the king. So Mosaic actually allows our customers to have access to almost 5,000 plus decision-making points at any given point, which allows them to decide with a human in loop, what is an optimal time to bid? What is the optimal price to bid? What is the optimal time to discharge? What is the optimal time to stop discharge, right? So, and there, the value then keeps increasing for the customer. And why should the value increase for the customer? I'll come back to this in a second. Hopefully, I'll know how to come back to it. But the value to the customer is such an important part of making sure it's a sustainable business case for renewable energy. If it is not meaningful in terms of return to the customer, nobody's going to invest in renewable energy. If nobody is investing in renewable energy, we are going to continue having unsustainable practices of how we generate and consume power. And that is why making sure that it is profitable and useful for customers to generate that value is where the whole business case lies. I'm going to try going back and showing you a couple of more things. So I told you about the intelligence that has been built into the system, right? So if you look at this, if you're able to use the terabytes and petabytes of data that the systems generate on any given day, and have an intelligent way of analyzing that data, drawing the insights from that data, predicting the performance, predicting the failures, and you're actually able to make sure that the system stays available round the clock. To be able to do that, we have something called the remote monitoring and diagnostics, and we've built that right out of here in Bangalore. So which means across the world, our entire 30 plus gigawatts of installed capacity that we have can be remotely monitored. And that means that if the second a particular core or a node or a particular battery goes down, we would get the alert, we would be able to address it within the next 10 minutes, 15 minutes max, to be able to continue providing that round the clock, right? So talking about the digital service center, and I think there's a couple of things more. I don't even think we should. There's something called reliability engineering. How many of you have heard the term reliability engineering? Some of you have. It's basically, in simple language, it is your ability to understand the performance at a micro level of different components and know which components are useful for you to continue using in your subsequent products, or should you already swap out some of them in your current products. Loosely, that's what a reliability engineering is. It looks at data, it looks at performance, and that it informs engineering decisions on how you build products. And at any given point in time, the number of faults or the alerts that our AI systems throw up allows us to analyze that, and it allows us to continue improving the performance of our products and that of our suppliers, because not everything is manufactured in-house, right? So you're constantly helping the whole ecosystem improve the way their products are designed and built. So if I sort of summarize this, right? So when we say intelligent storage, energy storage, and there are enough and more energy storage players in the market around the world. There's, Tesla is one of our biggest competitors. We have enough competition coming from, Chinese players. But the biggest advantage that somebody could get out of an energy storage solution is the intelligence that can be baked in. And we've now come up with what we call as a smart stack, which is the most cutting edge energy storage solution there is in the market. And it sort of brings all of this together, right? So when I say it brings us together, what I really mean is how do these assets perform? How are we actually self-healing, building self-healing abilities within the asset to be able to say, so for example, within a battery, there's like so many cells, and if a particular cell is not functioning as it might not, how batteries work, the system should have the ability to override that particular one, and the system should have the ability to continue maximizing the performance of that particular battery core or battery cell, right? So I spoke to you about safety, and where safety becomes so crucial is if any of these were to ever get into trouble, which means like, there's we see so many news of, some battery catching fire on a plane and so on. So when batteries are involved, safety is a hazard. But you cannot afford a safety hazard with a product as large as this. So just for guessing, how large do you think a single product of ours could be in terms of weight? Anyone? Just a guess. Tons? How many tons? 10 tons? Well, our product could easily weigh up to 75 tons, if not 90, depending on, the version that you're looking at. And what that means is, if it is not built for absolute safety, then, there's no way, first of all, anybody is going to certify this product. There is no way any government is going to allow us to put it. So safety for us is paramount. And when we think about safety and AI, I think there's a very strong correlation to the reliability engineering aspect that I spoke, but also about how we manage faults, our ability to predict performance, our system's ability to shut down something if it foresees that there might be a problem before it occurs, right? So when you think of all this, and then the last one, degradation. The other issue with batteries is they degrade. And when they degrade faster than they should, then it means you lose value. So the Mosaic software that I spoke to you about has the ability to manage the discharge and recharge cycles in the most optimal way. That means that your batteries will not degrade faster than they're supposed to. So put together, in one of the previous sessions, a lady did ask the question, don't we have important problems to solve leveraging AI? And I would say, yes, AI is definitely solving very, very important problems for humanity, because if we are not able to do this well and not able to leverage the power of AI to make sure that these systems continue to support the evolution of human race with the use of renewable energy, I think we really have a huge opportunity. I spoke to you about this. Okay, one last thing before I do it. Most of this is actually done out of here in Bangalore. So we have our largest innovation center based in Bangalore. Fluence, of course, like I said, we operate across 48 markets. We're headquartered in the US, but we do have a pretty significant innovation hub set up in India, and a bunch of this work gets out of India in terms of design, in terms of management, in terms of delivery. So on that note, I would leave you with a picture of Smart Stack. That's how the product looks, the one I spoke to you about. And this is really our mission. We believe we are transforming the way we power our world for a sustainable future. Thank you.